So hi everyone. Thank you for joining the presentation, or also as we would say in Montreal, bonjour à tous. We're going to explore how we're creating real-world interactive wind farm projects for stakeholder engagement. All right. So engineering firms don't have super cool names to call ourselves, so I'm called manager. But in other areas, I would be called a technical director. I manage a team of great artists and very talented people. I've worked in the simulation industry for more than 24 years in civil aviation, in defense. I've had the opportunity to work on digital twins for power plants and other types of projects around the world. And various technical understanding acquired throughout these years have given me the possibility to explore new fields and understand certain things. Thanks. So for those who don't know WSP, as an engineering firm, we're 69,000 strong and recently increased our numbers with colleagues sitting in the first row. So we're happy to be very international presence, but we're thinking international with a local solution approach, meaning our customers are important to us and each individual customer gets that international level of solution applied to their projects. So our team focuses mainly on creating solutions for visualization, typically for the past 15 years, creating what we usually know from visualization teams, stills, animations, different simulations that are required. And as you know, most of the time it's like at the drop of a hat, can you give us this in 2 or 3 days? How quickly can you do it? So we have to be creative in our approaches and use technology that goes a lot faster, quicker. So what is stakeholder engagement? It's the big question that maybe it's on your mind, but to us, it's a daily thing. Stakeholder engagement is the process by which we all contribute to the decision-making of a project that will come to be. As we are all part of our communities, we want to make sure that what's going to be built is up to our expectations, either in economic development, in aesthetics, and much more. So how do we work and how do we create projects that help support these communities to make sure that it's not just the big client or corporation that comes in and builds anything without consideration? So wind farm projects, that's the main idea today, even though we'll expand a bit at the end of the presentation. Simplicity and its complexity. Now, for those of you who have seen wind farm projects, they're very tall structures, very punctual in the landscape, so you can't miss them once they're put into place. They're usually put at the top of a mountain or a hill because that's where they'll catch the most wind. So obviously the most visual impacts for the communities. These projects are huge. They cover more than 40 by 40 kilometers of size. So increased topography that you can't necessarily go to or walk to acquire pictures on an easy basis. So you need a data management solution that can handle all of that. And each project can contain between 20 to 500 turbines. So all of this put together creates a visual accumulation on the landscape and making sure that the tools are there to minimize that impact. We want to make sure that we give them the proper tools and solutions to our customers. So a wind turbine, just in quick terms, it's made of 3 components. You've got the blades, the turbine, which actually is generating the electricity, and the mast. So some of these are 100 meters high, more than 100 meters high. They can reach rotation speeds of 160 kilometers at the tip. And for safety reasons, they have different cutoffs so that when the wind speeds get too high, they don't get just shredded apart and they can be turned off. Now, these turbines create various sensory impacts to the local communities. Some of them are more perceivable than others. So the spinning blades create stroboscopic effects when the sun is just at that good angle, when usually end of day or early morning, and you'll get that feeling. For local residents, obviously, that can be an issue. Their large size and height cast long shadows. So if you have different points of interest in your landscape, you don't want to have a cast shadow all day long onto your property or various infrastructures. Having obstruction lights at the top of a 120-meter high structure that blinks all night, and depending on the height, you can have some on the mast too. Obviously, that can change your perspective on when you look outside the window. And it generates noise at different frequencies. We'll do a test. I'll demonstrate that in a few minutes. So when you put all of these together, what better way than to use engines? Because traditionally, we used to do photo simulations for these things. So good, but not good enough. On the top image is the existing landscape, and on the bottom is the photo simulation integrating a typical turbine. This obviously helps establish the look and feel for countryside and different areas, but it doesn't cover a super wide angle. It doesn't help you get the big picture, as we would say. So in stakeholder engagement scenarios, most of the time it's hosted on site with a limited number of hours and through a presentation similar to this, where you've got different experts in a room and presenting their content. But it was always 2D with a couple of snaps, and things have not changed a lot since then. So the project is partially captured, but not in its fullest. You get to see things, you get to see charts, a lot of different things, but you don't get that immersion. So we felt that within the team that it was time for a change, because the traditional approach were done in large assemblies with fixed dates that lasted a certain number of hours. But we know that with our hectic lifestyles, people want to have access to that information anytime, anywhere, during the day, during the night, based on their schedules. So how do we change that? How do we go beyond the traditional image that we were doing? And in public presentations, our customers kept getting the same questions, which are the same questions you would have sitting in one of those assemblies, being, what will I hear? What's the color of the paint that you're going to put on? All of these things affect your level of reception or level of appreciation of the project, and you may decide to be against or for it, but that's up to you to decide, given the right tools. So how did we help our customers present their projects in a way that really lets them engage during the design process until they decide and get all of the proper permitting? So we needed a powerful engine that offers the possibility to load and display large data areas. We can represent accurate sun angle based on geographic locations. Remember, this is real world, so we're not faking anything. Day and night lighting to get those blinking lights I talked earlier about, or other stuff I'll explain a bit later. Has multimedia functionalities, can be customized, and can generate photoreal visuals. So, spoiler, unreal. We've been working with it for 4 years now within the team. It's really helped us move forward into that space and connect with our clients. So typical data inputs for wind farms. We've got the sound simulation or the acoustic analysis coming from engineers. These are data charts with dB levels and wind speeds at meters per second and all of these amazing technical things. We have GIS data coming from government agencies that make it available or the customer supplied. We get accurate topography or LiDAR based on the region. And obviously the location of these wind farms and each turbine and satellite imagery. You put all of these things together and each one has a specific aspect of complexity to it. For instance, if you're in a remote region far up north in Canada, you won't get LiDAR. If you get good topography at a 5-meter resolution, you'll be lucky. If you're also in the north of Canada for certain areas, you're going to get 5-meter resolution imagery. So all of these little details start to add up, and we want to make sure that we give the data in a acceptable quality level that will suffice the needs of the client and also the communities to which it's going to be presented. Now, our software workflow to ingest all of this data is quite simple in a certain way. You've all seen presentations all week about how do you ingest the data, how do you prep it, and how do you make it work. But I'm going to give you an insight on this. Even though everybody says it's an easy in, it's an easy out, it never is, right? The data formats aren't optimal. There's holes in the data. There's missing coverage in certain areas. There are limitations to the 3D model that we receive, gaps, flipped faces, all of these things. And so there's a process in the background that needs to be done to ingest all of that data, put it all together, and make it work. So we use, for different types of projects, the example we're going to be looking at in a few minutes is a flat approach. It's not a 3D tiled world. It's a tiled area, but not a 3D tiled using cesium or Esri solutions. So when we work with these data types, it's really difficult to acquire it sometimes. Like I mentioned, LiDAR doesn't always exist. LiDAR isn't the latest revision either of the year the customer is presenting his content. So it creates expectations and limitations throughout the project wheel. So I have 2 demos for all of you to look at. I'm going to try and work this through in an efficient manner. Let's do this. So we're actually going on our cloud-hosted partner, Arcware. We find that cloud hosting really gives the possibility for people to connect with the project at any time of day, compatible with different tablets, iPads, and so on and so forth. As they would say, pardon my French, everything's in French for this one because it was presented to a local community. Before I start off explaining what we designed and developed in here, in Quebec, we have an agency called the BAPE. This agency regulates the social acceptance of projects, and depending on the level of complexity that the project offers and the impact that it has on the community, some may or may not need to present during those assemblies. But when you're called up as a company to go and present to that assembly, you need to be sharp because they're going to have the go, no go for your project. They may come back with some recommendations or improvements in which you can adapt the project, but nevertheless, it's quite a grueling aspect. So that's why the customers are coming towards us, so we can present content that they can present to those to that bureau and make sure that everybody understands what it's going to be. So through 3D, when we started at the beginning, we had 5 different functionalities. We're now up to 30 plus functionalities. Every day we keep adding new ones based on inputs that our customers give us. In here we have POIs, so points of interest. These different points of interest I can navigate to by simply clicking and seeing what it looked like from my house. Now, some of you may already be thinking, texture level is a bit low. Why didn't they go photogrammetry? Could have shot a drone, could have gone with LiDAR data and different things. Well, this is exactly the example I was talking about earlier about how we're limited to the data that's available and the age of the data that's there. Also remember, we're talking about public consultations, stakeholder engagement. So why would someone have their property be mapped out in a photorealistic approach and not the other one? Why would the customer invest for that specific one? So we keep everybody on the same page, everybody's level, and we position different POIs. We're working on connecting the Google Map API to this to make it even more accessible. So you're going to say, yeah, now I'm at the location. I can easily move with my keys and so on and so forth. But because all of the data is separated in different layers, we're actually showing and able to turn on and off what the landscape looks without your existing constraints. And that gives it a second level of acceptance by the local communities and stakeholders, because suddenly you're not hiding anything behind the veil. You're not saying, well, we chose this spot for the photo simulation that I showed you earlier because we don't see anything. No, actually, we don't see anything because you won't see anything. If I circle back to the data we were talking about earlier, and with the forestry information, again, in Canada, for certain provinces, we have access to attribute tables that give us the median height of the vegetation in those areas, and also the type of trees, deciduous, if it's the type of species, coniferous, all of those things. So it really helps us ingest that data and put it all together to create visualization. Now, for various purposes, when I said we've continually increased the number of possibilities, we have a dark mode so that they stand out a bit better, a bit crisper. We can change the orientation of the blades based on the wind direction. Now, this is not the actual wind direction. Because we're doing design and public consultations, we're not doing operations. So we don't have to link it into a direct feed of a weather service. It's mainly how do we demonstrate it. Because you'll be probably just like me, if I'm at location number 11, and I'm looking at this one, whoa, live demos, right? So at number 11, if I want to look in the direction of my farm, where is it? Let me figure it out. There they are. We can actually see the different impact that it has facing you and if it's perpendicular or front-facing. Not the same thing. We also added a night mode, and take this into consideration. This is not a calibrated screen. We are not in a calibrated environment. So usually the night mode, we don't show it in public assemblies for various reasons. Only in public assemblies, but we disable it when we go online so that people don't have that issue. And we can see at night, oh no, sorry. Here's the night. And here's without the lights, and you should start seeing little light points when I turn it on. Please come on. And they should be blinking in the distance. So by mixing all of these different approaches, we're suddenly creating a realistic landscape that talks to the people that are locals, and they can understand the visual impact that their projects will have to them on a daily basis. As a consultancy company, we're not there to judge on the quality of the project or anything. We're just there to make it accessible to people. If I flip back today and add one extra thing, being in Canada, we have winter. So this was taken 2 weeks ago. No, just kidding. We still have pleasant weather right now. This is actually a 6.5 kilometer ski trail for cross-country skiers in that area. And different parties mentioned that they would like to know what would be the visual impact for them as they go into the landscape and appreciate the environment. So using different assets from Marketplace, thank you Marketplace for all of these, we got a awesome visualization. So you'll see my cursor move around until I hit the play button, and then the camera's going to reset. There we go. So we're going at natural speed. 6.5 kilometers for a skier. What are you guys doing for lunch? No, just kidding. We'll skip around. So knowing that our customers don't have time to waste and the in-betweens they may want to skip to, we added a quick travel button. This is far faster than any Olympic skier for sure. But as you can see, at any time during the demo, the ski ride, we can turn on and off again the visibility of the existing vegetation so that they get full transparency on what is currently on site. This is existing conditions. And then when we turn it off, we can see by highlighting our turbines which ones are going to be added. And as I mentioned, we can turn around in any direction everywhere. This is a 30 by 30 kilometer area. Again, lots of data being processed. We used the topography data. We used LiDAR to counter-validate. Luckily enough, we had the LiDAR for this area. And we also had reference pictures of a site we're coming up on. So right around here, we have this great big opening. And I'll show this a bit later, which has a corridor. We're very proud of our energy, and we put them very visible in our landscapes. Sometimes a bit too much, but nevertheless, it's quite awesome to have all of these infrastructures being represented with the vegetation levels and being able to turn them on and off. I'll just skip to the last point, just for the fun of it. So somebody actually walked, and that day they snowshoed the whole thing because of weather conditions, but it was really, really cool to have the exact representation. And as you can see, using Quixel Megascan textures for the ski, it really looks like a winter wonderland. So we're getting to the end of our trail. A little less excruciating than if you had done it by yourself. And again, turning them on and off. So we're quite close to them at this spot. This is the closest spot people will see them. But with the natural vegetation, again, we only see a couple of blades spinning in the environment. This is one of our projects. I'll flip to our build. This one's in English. You're already hearing a little sound in the background coming through the speakers. This one was specifically made for a customer that wanted to add the acoustics to the project. And we're at a 400 plus wind farm. And you're going to think, well, 400 plus wind farms, that's going to be super noisy. Not necessarily, because the spacing between each is about 300 meters and sound cones die off quite fast. So what we did is, again, we typically do this in a calibrated environment with a sonometer or a sono device that gives us an exact reading of 60 dBs. Watch your ears. I'm going to leave it like for a second. It's just a reference tone, very annoying. And this helps us set the baseline for the sound. Again, this is only done in public presentations and assemblies because people who have different speaker configurations, people who have different hearing disabilities, we don't want them turning it up until they actually hear it. That's not the intent. The intent is just to get the perception of what the sound will be. So we digested a lot of data coming from the acoustics team in CSV format. We took that, we piped it into Unreal. We made we found the correlation, we calibrated everything. And if we move to one of these spots, you can actually hear the change as we progress in the meters per second. For those of you who are less familiar with these types of conversions, 3 meters per second equals about 12 to 16 kilometers per hour. Well, precisely, I can give you the numbers. And the 7 is at 28 kilometers per hour. Some of you may ask, why didn't we go above 7 meters per second? Well, it's the acoustics team that is inside of WSP that developed these models. And after a certain speed, there's no increase in sound. We just hit a certain threshold. So even though the wind is going at 90 kilometers per hour, you would not get an increased level of sound. So in this one, we're able to move from different points of views, but also we added the different time of day. They were experimenting with different sheens on the masts for the different paints and wanted us to test it out on using PBR textures. So we were able to quickly iterate different concepts and different approaches. I'm going to switch to another location, but at any time, again, I can move around and be in full control. Let me go to day so that you actually see it. This is the landscape. This is the layout. So there's a lot of them. And we've got more than 20 reference points, 27 locations within the project to capture all of these things. And what's wonderful by being into such a huge company such as WSP is that you have access to all of these experts that contribute to a project and make it bigger. So we're using the acoustics team. We're using the lighting and the lighting team that uses AGI 32 to validate certain levels of light intensities, and we map that into the software. We've got particle dispersions. Obviously, if you got big plumes in different industries and how they are represented in 3D, but today's a wind turbine, they don't generate any plumes. It's clean energy. So again, in here, we can change the direction and all of that. So if I go to time of day, sorry, if I stay in time of day and I go to a different visibility level, we could actually calibrate this for a 500-foot visibility if we use airline terms, Cat 1, Cat 2, Cat 3, or just, is it foggy today or is it a clear sky? That type of approach. So if I go on the mountaintop over here, and I look down in the valley, right now we're at medium visibility, and using low visibility, only 2 or 3 stand out. By using data for each environment in which we create, obviously we do some research and see the number of median days of fog and the number of the fog density and all of these things and the fog heights based on weather patterns, we're able to replicate very close to real life conditions, which gives communities, stakeholders, which we all are, a better sense of what is going to be in your backyard. And then it can open up the dialogue. I'm just going to switch back to the presentation. So, to the left, actual picture taken on site. To the right, the 3D that I presented a few minutes ago. So for us, the level of realism is not necessarily the pixel density of the LiDAR or certain things. It's, do I recognize the space, and can I associate that area with my local environment? So when we look at all of this, we created custom functionalities that cover a whole slew of features. And within these, I think I have to go one by one. We have the time of day, the weather, the seasonal, acoustic studies, virtual laser pointer. I didn't demonstrate that because we integrated it into a project recently that hasn't been released officially. And the laser pointer distance is actually amazing. You click on an object and we are able to move back so that you progressively see the visual impact that it has on the landscape. We actually had to pull back 40 kilometers for that specific project from the point of where it was seen and 40 kilometers back. This opens up just a brief discussion about 40 kilometers on a flat surface has a certain impact, but 40 kilometers when you're starting to take into consideration the Earth curvature can start having that extra level of precision. So we're currently exploring those solutions to see what is the actual percentage of visibility based on these, based on it. We're also using viewshed analysis data to create different review sessions with our customers so that we can place different turbines at different locations based also on their specific data that they need to cater to. For instance, wind speeds, wind directions, and maximum gains from different locations. So we put all of that together and we get what we demonstrated. Quick travel points of interest. We tried to be as open as possible and we're continuing to evolve on that, making it even more accessible by putting in your local code and your zip code in the US. And just by typing it in, you would be able to get to that location. Keyboard and menu navigation, because we know everybody has different skill sets using 3D. Some will be very tactile, others will be very hands-on. So we give that flexibility to everyone. Finally, the audio playback of pre-recorded narration in multiple language. What we're when we present this, we're presenting to different French-speaking, English-speaking communities and others. And we want to make sure everybody understands the same message. So we can actually flip between French and English in some of our interfaces. And for people who have hearing disabilities, we they can actually play it or have subtitles go along with it. So really trying to get everybody involved, not just thinking of the super high-tech solutions. I'll just go to the next one. So some of the takeaways from the project. By listening to our customers, we're able to keep the functionalities growing, and we're adding every week, as I mentioned. The acoustic and simulations and nighttime, that is a bit tricky. It's not for every presentation, obviously, but it does play a lot, and we've gotten great results, good feedback from the communities as they see a more engaged approach. For us, I was talking about how it was cloud hosted and everything. We don't measure the success by the number of viewers that we got on the site. It's not, yeah, we got 1,000 hits. Yes, it is a metric that we use to see how many people we've reached in the community, but it's not our single factor. For us, it's really the final output of decision-making and making a better project in the end. Also, due to remote locations and tech infrastructure, luckily here at Unreal, amazing hardware, really amazing setup, which makes it easy to present. But when you're in remote communities where LTE sometimes comes in at a very low bit rate, you can't start doing different presentations. So we actually shipped and bundled different computers to our customers so they could present on pre-calibrated hardware. We're exploring different things, dabbling, and we're starting to see, we're using 3D printed turbines from the customer, putting them on a table and then generating in augmented reality the whole landscape. Harder to present, obviously, but that's a direction in which we're going to make it even more accessible with larger crews or larger groups. We were also asked, can you do VR? Yes, we can do VR. But when you have a public assembly of 200 people, you don't want to put that headset individually on everybody's head. So not the best approach, but nevertheless, it is compatible if the people have the hardware at home. So moving forward, where are we at? We've expanded our approach and we're applying it to transportation projects, and we're already applying it to mining projects. I have a few. If you have questions at the end, I can open it up and access it through the web. We're improving, exploring a better data management automation solution, because as in engineering, it's never fast enough that we always wanted. But I think it overall in every industry, demonstrated here this week, all our customers are more tech savvy. They want their content as fast as they can. Accessible through cloud hosting and making a true digital twin, interacting with other solutions coming from other providers such as iTwin and by Bentley. For us, it's being part of the ecosystem and making sure that the project answers the engineering qualities that it needs, that it doesn't fall over, that it has the proper height, that it will generate the proper number of megawatts. We don't really care about that part. But we do care about how it gets used in the end. And once we go into, when these projects go into operations, we want to be there for our customers for health and safety training so that they can use these 3D models and interact. We're using it internally at WSP to train our teams before they go on site to do site assessments. And we're deploying it at a larger scale. So when we look at all of these solutions, it's making it accessible to people so that they can make the decision themselves. Final note, my graphic artist really insisted that I keep this amazing little stick figure representation of me, so I thank her very much. It's quite a nice gesture, but it's a team effort, so I'm not the only one here. I'm the only one presenting, but we're a full team. Yes, very French-Canadian names in there. So if you need help with pronunciation, just ask me and I'll definitely... Our the technical artist who created all of this is Rémi Batalon. He wasn't able to join us at this year. So that concludes, as we would say again in French. Merci beaucoup. Thank you. And QR code if you need to reach. Thank you.